Welcome back to Build 2015. This is the Internet of Things Show Live. And I'm Larry Larson, joined with Gavin.
I'm Steve Teixeira. I'm the guy that wants to put Windows on all these crazy little devices.
Pete Brown. I work on apps for musicians and IoT devices.
And Sam George. I run our Azure IoT efforts at Microsoft.
Great. And so let's talk about some of the announcements that we've had this week.
So I gave a session on AllJoin here. AllJoin makes it easy to interoperate with IoT devices. We built it into Windows 10, and we had the CEO of Insteon on stage announcing AllJoin integration for their Hub Pro 2. Mm-hmm. That's one of the announcements that we had.
What haven't we announced?
Right.
Build, availability of Raspberry Pi, Windows built for Raspberry Pi, for Minoboard Max. Cool stuff we can play with. We announced some partnerships yesterday with Arduino, with Raspberry Pi Foundation, and with Hackster.io.
Great. And what is the device that you've got in front of you here?
This device is an enterprise quality robot, industrial robot. It's actually used to make automobiles, believe it or not. What it is, it's got a couple motors inside here. It's got a Raspberry Pi on top. I have a universal Windows application that drives this thing. Through the I/O pins on my Raspberry Pi, I can make it go forward, I can make it go back, I can plug in an Xbox controller and drive this thing. So we've got it upstairs for folks here at the conference to kind of mess around with and learn how to build these things.
Great.
And that's all C# code on there?
It's all C# code. The apps that we've kind of pre-written are all C# code, but in fact, since it's universal Windows platform, I could write it in C++, I can write it in any UWP language.
Yeah, awesome.
Great. And so we'll be taking your questions live too. So if you go to Channel 9 page, scroll down below the player and send us your questions and we'll take those live. Cool. So Gavin, tell us a little bit more about what went on this week and what other things we're going to be talking about.
Sure. Well, so I can give you the perspective on AllJoin, which is the technology I'm here to talk about. So a little less than a year ago, Microsoft joined the AllSeen Alliance. AllSeen Alliance is the organization around AllJoin, which is an open source, cross-platform device communication framework. And it's the largest open source code base that we've built into Windows. We built it into Windows 10. We made it really easy to write universal Windows apps that can connect to and discover consumer IoT devices in a home setting, something of that nature. Mm-hmm. So that's a little bit about what I've been up to. Sam, you've been doing some cloud stuff.
Yeah,
right?
We have we recently announced not just the Azure IoT services, but an upcoming Azure IoT suite, which is a set of apps that developers can provision quickly, get started with a proof of concept for free, and then take that same solution and scale it up to extreme IoT scales. Yeah.
Great. So we've got a question from James. He says, if using an Arduino with Windows 10, is special hardware required?
Yes, an Arduino.
All right. Easy enough.
That's my facetious answer. Yes. So I'll show this a little bit in my session in a few hours this afternoon. But the way we've implemented this is I can take an Arduino, which typically is a microcontroller-based platform. So it doesn't run Windows. It doesn't run any operating system, in fact. And I can take that Arduino and then I can pair it to a Windows device. And I kind of get the best of both worlds. I can use my Arduino to really drive the hardware in a very deterministic and secure and reliable way. And then I can use Windows to offload all the processing. If I wanted to speak AllJoin, if I wanted to talk to the cloud, I can use Windows for all of those capabilities. And then we've made it really easy to talk back and forth between an Arduino device and a Windows device.
So Steve, if someone is going to write code that's going to control a robot like this, tell me about the developer experience. Where would you start? I'm assuming in Visual Studio 2015.
Yes, that's the cool thing is because it's just Windows, I would start in Visual Studio. I would start by building a universal application. We've got some small SDK extensions that people can use to get at some of the very IoT specific stuff. But the idea is if you know how to build an app in Windows, you're now an IoT developer. You pretty much know what you need to know. Learn a little bit about how to drive the pins and how to do GPIO through the hardware. Other than that, if you're a Windows developer, you're an IoT developer.
Great. All right, got another question from Al, longtime Channel 9 viewer. Thanks for watching. It says, how does Winlot work with things like GPIO, PWM, and SPI?
These are all implemented as Universal Windows Platform APIs. And so from within the context of a UWA, I can access SPI, I can access I2C, I can get at all the buses that I would expect to get to. The other thing that we're working on, although we're not releasing this at Build, it'll be probably a couple months out, is support for Arduino wiring within my universal app. So if I don't want to use UWP, or I want to bring language that I've got from an existing Arduino sketch, I can easily go do that and run that as well.
That native support is really awesome because compared to embedded Linux development on the Raspberry Pi, for instance, it's really easy to do a bunch of stuff, but to find GPIO code that would work, I had to get some code off the internet and I had to run it as root. So to have namespaces that you can just enumerate in your code and use IntelliSense, I'm really looking forward to playing with that actually.
Totally fun.
Yeah.
So one of the things that one of our partners is working on, though, is building upon that to add in support for Gadgeteer on top of those same APIs. So if you're familiar with the microframework stuff, you'll be able to use the same shields, the same devices, the same sensors and everything. But it shows how complete this API set is that we can build right on top of that, just like we are with our microcontrollers. So
in fact, here at the show, we're showing AllJoyn support ThinCore, which is the sort of lean and mean version of AllJoyn, running on .NET Micro Framework. I showed an early preview at WinHack, and they've actually got it running up in the booth.
That's right.
So it's very fully featured.
And our team is working on doing the work in .NET Micro Framework to make sure that there's high API compatibility between the code I would write for a very small microcontroller device in .NET Micro Framework and take exactly that same code and run it on a larger device with a full Cortex-A powered CPU.
Great. And Pete, what are the boards you're holding there?
I brought toys, right? So not as cool as the industrial robot over here, but so one of the partners, Secret Labs, just announced the Netduino 3 Wi-Fi and Ethernet this week, which are a big deal because he's specifically looking at better Azure integration with this. So having onboard Wi-Fi is obviously quite important for doing that, and having onboard Ethernet and like a good solid networking stack there is good. The other thing I brought is the prototype shield or prototype hat for Raspberry Pi 2 that GHI has worked on to let you use all your Gadgeteer stuff. And they also did a smaller hat that they're working on here that has all the sensors built in.
Nice.
So if you want to do like an Azure IoT demo that has temperature and light sensors and all that stuff, just pop this in, use the APIs that you guys have written, and then you're able to access Azure and upload all that stuff.
That's great. Yep.
Great. We've got a bunch of questions here from Philip. What are the limitations of using Windows 10 in the IoT device? What can't I do?
The chief difference between Windows 10 IoT Core, which is the small version of Windows optimized for these devices, and Windows Mobile or the enterprise version of Windows for large devices, is there's no shell. So there's no Windows experience, there's no start menu. The shell for my device, if in fact I do have a head, I can implement this as a headless device with no screen as well. But if I do have a head, the shell for my app is the app I wrote. So I get to define the personality for my device. Things you would expect, because there's no shell, there's no inbox application, so I don't get the travel app and I don't get the mail app and things like that. Other than that, it's a complete version of Windows, including I get the identity model, I get the security model, I get the enterprise manageability actually. So everything, these things can do Windows Update. Everything that it means to kind of be a Windows computer is supported by Windows 10 IoT Core.
And because it's built on one core, there's a common platform. We showed writing a lighting control app that would deploy to, it was a Minerboard Max running Windows 10 IoT for small devices. Same app, deploy it locally on your dev box, runs the same, like you said, the shell is the UI in your app. So the whole universal Windows app model with UWP is definitely, this is a huge part of that story.
That's right. It scales across both Windows editions. I can run it on a desktop or a phone or on a small IoT device or a server, an Xbox, a HoloLens, and also different hardware platforms. I can target ARM, I can target x86, switch back and forth very readily. Zero changes to my code. It's literally just change the deployment target.
In the audio session yesterday, so Bala was able to show taking a regular USB device that uses our new MIDI stack that's in Windows 10, unplug it from the PC, right? Just go plug it right into the Raspberry Pi, deploy to the Pi, and it just ran. So I think that's really the power of that.
Super cool.
Yeah. So tell us about the video that we saw in the keynote today. What were some of the things that were in that video that you worked on?
That was probably one of my favorite days on campus here. We spent a couple of days going around the buildings that you guys work in, filming all the people that are doing great IoT stuff. So we saw lots of offices full of oscilloscopes and toys and robots and the stuff that went into building the B-15 robot that showed up in the keynote yesterday, the big HoloLens robot. all the work that Lou was doing on the hardware for that. Absolutely amazing stuff that we were seeing in there. And what was really interesting about all those interviews is the building is just full of makers. Like everybody there is not just doing this for their job, but it's their passion. It's something that they do at night when they get home. Lou's working on robots at night. He's the person who created the first modern extruder for 3D printers, like the current way that extruding is done there. So these are guys that are really, really into this. And it was a really fun video to record. Too much to say.
Yeah.
Way too much.
All right, from Bill Walter, where are some places to go to find IoT kits to get started with?
Gosh, lots of options out there. So for the Windows platform, we're supporting 2 hardware platforms today. One is the Raspberry Pi 2, the other is the Minoboard Max, which runs an Intel x86 CPU. Because it's Raspberry Pi, we're trying to support a lot of the existing hardware ecosystem for Pi, so I can buy weather shields and sensors, and I can just use those things. Arduino makes a giant host of add-ons that I can use and different kits that I can use to building robots, building temperature sensors for my garden, lots of crazy applications. A couple days ago, I found I was short on some parts. This is the other bad thing about being a maker is you're like, oh man, I don't have a wire. So, right over across the street, there's a Radio Shack. I went, bought some parts, and I was amazed. They have like a whole aisle of kits, different kinds of sensors, wires, Arduino kits, and it's easy to get started, super easy.
Yeah. All right, from Dan, how many different IoT devices will run Windows 10 on launch?
Yeah, at launch, so we haven't disclosed the exact number of boards we'll support at launch. Today, it's Raspberry Pi 2 and it's Minoboard Max. Lots of other partners we're working with. We're working very closely with Qualcomm on their Dragon board. That's one that we hope to support by launch. A couple other partners that I can't talk about yet. Obviously, the goal is to maximize the number of boards in market and the number of systems on a chip, CPUs in market that will support running Windows 10.
This is a great place to start now, if you want to get started now. From Chris, what cool IoT projects have you guys built, at least that you could share with us? I'm looking at you, Pete. I know there's something going on there.
So it's fun stuff. So I've started working with using Windows on Raspberry Pi as the brains of synthesizers.
Yeah.
So that's really, being able to take the type of app that I would run on a tablet and being able to embed that into a synthesizer with a keyboard and knobs and all that stuff is what I'm really interested in. We've built some silly projects, like I used a moisture sensor and built a diaper monitor shortly after my kids were born. Unfortunately, it's like 2 big spikes that come through, and that doesn't go over too well with like my family when I did that.
I found my nose was the best sensor when my kids were that age.
The kids come with their own alarm anyway, as I quickly learned. But
are you thinking Kickstarter for that, Pete?
Yeah, that might be really good for that. Good market there. Maybe the adult version, I don't know. So there's those things with lots of robots. I think all of us here have built umpteen thousand different types of robots and stuff. But I'm really interested in like all the things that our existing .NET developer community has built in terms of devices. Like people are doing home automation with MicroFramework or with Arduino and stuff, and they're doing things like simple things like garage door openers, but they're not limited by what you can go and buy in a store. They're just like, what, I don't see exactly what I want in the store, I'm going to go make it. And they get it done. It takes them a day or 2 to get it done, and they have that in their house and they're able to use it. And I think especially with the stuff that's going on with AllJoyn and the stuff that's going on with Azure, between the 2 of those things and these new devices that we're coming out with, I think people are going to be able to make some really fantastic stuff over the next 6 months. So I'm really excited about that.
Any other projects on campus that we can talk about?
None that I can talk about.
Nothing we can talk about.
Okay, all right.
Our 3D print team actually is quite active in building custom 3D printers. And they took one of the 3D printing platforms apart and built the turntable scanner that we're showing here, where we're using a Connect V2, which that's 3D scanning functionality is actually built into our 3D Builder app, so you can very quickly get a full color 3D model yourself. It's pretty cool.
So if you are a maker, though, and you're walking through buildings in Microsoft, there are places where you're just like, wow, what is that?
Oh, yeah.
What is this? What are they working on? There's so many just different projects that you just are amazed.
Working on the IoT team, our halls kind of end up with this stuff in it. There was a day where I walk into the bathroom and I hear a click. I look around. I didn't step on a landmine, so I look around. And and there's this thing counting ingress and egress into the restroom. And I think they were just kind of testing sensors, and they thought this would be a handy way. I think ultimately, after a few days, it creeped the team out that they were counting. Someone was counting.
Not the
people coming
bathroom,
in
do
and
the
out of
kitchen
bathroom.
or something.
Yeah, exactly. That was, I don't know if that was the coolest project, but it was perhaps the most disconcerting project that I've seen.
So Larry, one of the things that we just did for this keynote is one of the makers that's as part of the garage. So we have the garage on campus, which everybody's able to go in and use laser printers, laser cutters, and all sorts of cool stuff. He built a Tesla coil synthesizer. I don't know if you saw this, had 2 5-foot-high Tesla coils. We had sort of snippets of it at the end of the video. Nobody would let us plug it in on campus. So we ended up bringing it down to a fire station in the middle of Redmond. They didn't have the right kind of power supply there, so we rented 2 big, like 10,000 watt generators.
It's like one of those 1.21 gigawatt generators.
Yes, exactly, right. So we had those running outside, and we're able to record that and have that going there. We're probably going to bring it down to Summer NAMM this year in Nashville, because they'll let us have it on stage because they don't have anywhere near as much electronics on there. But like that's somebody in the Maker Garage on campus. That was their idea to build this thing. And create a synthesizer out of it, and generally shoot sparks that are 8 to 10 feet long at unsuspecting people on the way by.
All right, from Mayor, can all, quote, all IoT devices talk to each other with so many companies working on different products, technologies, and platforms? That's probably where AllJoyn comes in, right?
Definitely, yeah. So AllJoyn provides a set of standard device profiles. They're defined in what's called introspection XML. And that's really the basis of the interoperability story with AllJoyn. But as an extension of that, there's the cross-platform code base. So regardless of you're running Arduino or Raspberry Pi with Windows or with embedded Linux, iOS devices, Android devices, it's a cross-platform story. It makes it really easy to implement producer functionality, which would be like a device that you're going to control, or consumer functionality, which would be like an app that would discover a device. So we've, like I said, built it into Windows 10. We've got a C API. We've got a UWP API. It's a great developer experience on Windows 10. But regardless of which platform you're on, microcontroller, full-fledged high-level operating system, those devices can talk to each other. And it's not the only technology for interoperability, but it is a great way to reduce the surface area that's required when you write apps for interoperability. So things like Thread and OIC, these technologies complement each other.
I'd say certainly from the on the cloud side, common pattern that we see is customers using Cloud Rendezvous to communicate with different devices, and in fact, different sort of subnets almost, if you were, like you might have a field gateway speaking Thread and another one speaking AllJoyn, but you want to interoperate between those or extract value from those with analytics across the entire fleet, and that's where we really see cloud shine and where customers are driving value out of IoT with Azure.
I think there's a short answer to Kieran's question, which is that, or it was the question before Kieran's, that all IoT devices don't talk to each other today. You buy some home automation gear, and you'll find why the Z-Wave thing and the Zigbee thing and this Wi-Fi thing, like they don't quite. It's really hard to get them all to talk. We're operating from a point of view that says, with our investments that your team's making in AllJoyn, Gavin. Devices want to be free. They want to talk to each other. They want to talk to the cloud in open ways using open protocols. And so that's the thing we're pushing on. While it's not true today, that's where you'll see us continue to push is let's get to a place where all devices can just talk to each other and all devices can just talk to the cloud. And then let's see what people can build when you get rid of all these walled gardens.
And then there's bridging technologies as well. So it's one thing for every device to be able to talk to every other device directly, but there's a couple things that are available now that are really interesting. Your team has built the device system bridge, which is a way that you can take things like non-AllJoyn devices and expose them as virtual AllJoyn devices, add layers of security, that sort of thing, add credentials. But there's also in the All-Seen Alliance what's called the Gateway Agent architecture, which provides basically a way to provide a sandbox local network environment for things like AllJoyn devices, and then to provide that bridge to the cloud, whether it be Azure or other clouds. It's that cloud relay type of scenario where you can access it remotely or have cloud-centric logic that's running.
So I want to jump down to Ken's question. Are Windows Crypto APIs supported on small devices?
Yes. Full crypto API is on the device. because the devices tend to be Cortex-A powered or x86 powered, there's plenty of horsepower there to support cryptography stack, full networking stacks there. It's not just kind of Windows. It's like literally the same binaries. It's really Windows.
Yeah. All right. And from Ankik, which Raspberry Pi device is good to start to prototype with Azure?
Sam, you showed this yesterday. What did you have up on stage?
Quite a few, actually. So we had ARM Embed Freescale board running ARM Embed 3. We had a BeagleBone Black running Ubuntu Snappy, and we also had a Raspberry Pi running, of course, Windows 10 IoT Core. All of those are great. Azure supports standard API or standard protocols like HTTP and AMQP for interoperation. There was another question that I just wanted to address too that I saw a minute ago around whether Azure supports bidirectional communication. So today we have our Event Hub service that's been generally available since the beginning of the year. It's a great high-scale telemetry ingestion service. We're doing somewhere north of about 18 billion messages per day worldwide through Event Hubs. And one of the things I announced yesterday is that as part of the Azure IoT Suite, which is coming out this year, that we're also introducing a service as part of the suite called the IoT Hub, which also allows not just telemetry ingestion, but also command and control. It has a facility for device identity, as well as a device registry, so you can store device state. And then finally, it'll also do device management, so you can manage your IoT fleet across standard protocols.
Great.
I think it's important to point out though that we've been focusing a lot on devices even so far on this, that without the additional support you're talking about, without the command and control, without the ability to do remote
Device
access,
updates.
exactly.
Yeah.
Without all of that, you don't really have a complete IoT solution. So
Right.
it's important to think of these things all together as
It
one.
is,
one
and
thing.
it's great. And it's great to start your prototypes sort of at the device level, and then once you get the solution, once you have that idea, then you start to see a lot of the value coming from rich analytics across an entire fleet, which is where we see people start to use Azure.
So there's a good question from Ali. With IoT booming, what is being done in terms of security and privacy?
Great question. So I think Steve should talk about this on the Windows 10 side. I can say from the Azure side, we of course support all of the rich industry standards from TLS to shared access tokens per device, as well as key vault encryption for encryption all the way through the system. We have some strong ideas about some additional security services that we'll have announcements later this year for as well on the cloud side. We think security is, certainly in the cloud, security and privacy are absolutely tantamount to IoT, and that it is very much table stakes. And you'll see us not only take industry best practices, but also sort of drive that forward. We had a talk yesterday on Azure IoT Security Fundamentals. I encourage folks to check that out. It talks about all the ways that you need to extend your thinking from just devices all the way through software on those devices and bring in the security lifecycle onto devices. But I think there's some amazing things coming for Windows IoT, and Windows IoT definitely adds a lot to the story that you don't see in other platforms.
Yeah, on the device side, I think you just start with what does a Windows desktop do for security?
Yeah.
And if you think about that as a starting point, and then you think about what's in market today, you kind of realize, wow, what's in market today maybe doesn't quite meet a desktop computer's bar for security. Lots of cases about baby monitors being hacked and people's Wi-Fi credentials being sent over open text and things, just kind of stuff like that. It's because people are having fun. They're going fast. They're trying to, serve a market and come up with great ideas. So we kind of, as a first approximation, say, okay, it's at least as good as the desktop. Then you kind of think about, well, what does an IoT device need that's differently? And there are a couple things. One is there's often no interactive user. So there's nobody to kind of type in a username and password if this is a device that's sitting off somewhere. And so I need a way to securely identify this machine, not just a user of this machine. And if I'm, for example, communicating to a cloud service, the cloud service needs a secure way to know, that really is a message coming from that machine. It hasn't been spoofed.
And I trust that software hasn't been tampered with.
And it's a trustworthy machine.
Right.
And then getting to that kind of trustworthy machine, the other interesting thing about IoT, which is different, like There's a laptop up here that maybe I could do interesting things with, but IoT devices are often unattended, just kind of sitting around in the environment. You'll find people that that enjoy the practice of going and finding those devices, maybe popping the plastic off of those devices and going, oh, that's an SD card. Let me put that in my computer and see what I can do with that SD card. And if that SD card hasn't been locked down with BitLocker, if the computer doesn't support TPM, it's at real risk of compromise. So these are kind of the things that we're thinking about on the device side in terms of how do we go a step further than just kind of PC phone level security.
And that's going to be one of the biggest barriers to the widespread proliferation of IoT, right? If we want IoT devices in everyone's home, if they're not totally confident about their data and their privacy, they're not going to feel comfortable turning that stuff on. You know, the old Band-Aid over the webcam type scenario.
That's right.
So.
I didn't know about that.
I use black gaff tape, but yeah.
He's got it right here.
I do. So that's all the time we have today. So we're going to wrap up here, and thanks for watching.